Welcome to 5-3 sum and difference identities for cosine. We're going to take a look at cofunction identities. We've seen these before where we have the sine of 90 degrees minus theta equals cosine of theta. That's the same with secant and cosecant, tangent and cotangent. In the notes, you can see it's also written as the cosine of 90 degrees minus theta is equal to sine of theta. However, I like to think of it a little differently. I like to think if I have cosine equaling a sine, or if I have secant equaling a cosecant, or tangent equaling a cotangent, then I know that those two angles have to add up to 90 degrees. But since now we have not only degrees, we also have radians, those two angles could also add to pi over 2, just because 90 degrees and pi over 2 are the same angle. So let's take a peek here. We have secant x equals cosecant of 62 degrees. So since these are co-functions, secant, cosecant, then we know that x plus 62 degrees must equal 90 degrees. Notice because I'm in degrees, I'm using 90 degrees instead of pi over 2. So solving this, I subtract 62 degrees from both sides. So x equals 28 degrees. So this is one solution to this equation where secant x equals cosecant of 62 degrees. So secant of 28 degrees does in fact equal cosecant of 62 degrees. B, tangent x equals cotangent of negative 54 degrees. This might be a time where you pause, try and solve it. But because tangent and cotangents are co-functions of each other and they are equal to one another, we know that the angles must add up to 90 degrees, and that will give us one solution. Now to solve this, we're going to add 54 degrees to both sides. C, sine of 7 pi over 6 equals cosine x. Again, we have two cofunctions equaling each other, so therefore the angles must add up to 90 degrees or pi over 2. Since I already have radians, I'm going to state this as 7 pi over 6 plus x equals pi over 2. I'm going to go ahead and use radians instead, since my original equation had radians in it. Now subtract 7 pi over 6 from both sides. I'll take this calculation over to the side. So we have pi over 2 minus 7 pi over 6. So we need a common denominator here. So 6 is the common denominator between 2 and 6. So we're going to multiply the top and bottom of this fraction by 3 to get 3 pi over 6. And now we're ready to subtract. We get 3 pi over 6 minus 7 pi over 6 is negative 4 pi over 6. And this can be reduced to negative 2 pi over 3. So reducing both of 4 and 6 by 2. Therefore, my final answer is x equals negative 2 pi over 3. Example 3, write cosine of 90 degrees plus theta as a trigonometric function of theta alone. Notice I have cosine of a sum, so I have addition inside my cosine function. Therefore, I'm going to use my cosine of a plus b formula, or my couscous formula, to get cosine, cosine, sine, sine, and because it's a plus here, I'll have a minus there. And my angles stay the same order. So 90 degrees theta, 90 degrees, and theta. So I have 4 quantities that I need to figure out. So I need to figure out what cosine and sine of 90 degrees is. 90 degrees is a quadrantal angle, so I will just write the coordinates 0, 1. So I have cosine of 90 degrees is 0 and sine of 90 degrees is 1. So let's go ahead and plug those in. Cosine 90 is 0, sine of 90 is 1. And here I have cosine theta. I don't know what theta is. So I will just go ahead and bring that quantity down. Cosine theta, same for sine theta. Now 0 times cosine is just 0, and then 1 times sine is just sine. So I get 0 minus sine of theta, or negative sine theta. Looking at the directions, it says to write this expression as a trigonometric function of theta alone, and there we have it. We have sine of theta. This is a trigonometric function of theta alone. So negative sine theta is my final answer. I hope you enjoyed this video. See you next time.